Guys, so what we're going to do today is we are going to go ahead and log into Wise. So I'm going to log into my student account. I set one up for you guys so that we could kind of all see the same screen because my teacher's screen looks a little different. So when you get to this screen, you're going to go ahead and click Launch. All right, so here we are. Perfect. This is exactly what we wanted. Uh-oh, I forgot to unsubmit, but that's okay. Perfect. Actually, I'll just leave it. I already completed this for you. Well, let's just go ahead and take a step back because I know some of us were having problems with writing a letter to the president. So when this check mark appears here, just kind of know that that's when you click submit. So I've already introduced myself. I've completed my letter to the president, and I turned it in. So the check mark is here. So I open the letter to the president. It's on your bottom right-hand corner. You're going to introduce who you are, what the problem is, what your plan is, and then a concluding paragraph, okay? So that's kind of the expectation for that portion of the assignment. So once you're done with that, oops, I'm so sorry. Let's go ahead and go back to the introduction, okay? Make sure that you click right here. So click this box, and then just make sure you click submit. So then you'll get that little check mark there, and I know that it's done. Okay, then for the next one, keep skipping me ahead. Okay, when you're adding pictures, so add this image to your letter to the president. To do this, you click on the picture, give it a title, and press save. So perfect. So you're going to open your letter to the president, put your cursor where you want the image, and then click insert note at the bottom, click on the image. Okay, perfect. So what you're going to do is you're going to click a note here. You're going to say before and after we can just say, let's just say Kilimanjaro Kilimanjaro 1983 to 2002. 2000. Jeez. Okay, then go ahead and click save. So now I gave this a title. Then what you can do is, so go ahead and say, maybe I want this to be here. So this is probably a problem, right? So we're going to go ahead and click. Oops. We're going to insert a note here, and then we're going to go ahead and do that. So see how none of the other pictures have popped up yet? That's because I haven't given them a note. So you have to make sure that you note them. Okay, then you can click save. So make sure you're following the instructions really precisely, okay, when you're doing this. Otherwise, we're all going to be a little confused. And I do know that this is kind of a new thing, so this is just kind of the step-by-step process that I'm taking you guys through. Then once you're done with that, so once you've added a picture for your letter to the president, you can go ahead and click submit, and then you've completed that assignment. So your check mark pops up again. All right. So very good. That was just kind of the introduction, but this next part is going to be extremely, extremely important. So let's go ahead and go to 2.1. So I really want to make sure that we're all understanding this. All right, so how does a chemical reaction release energy to power a car? It's a pretty good question, I think. So how does it? So we're going to start off with hydrogen and oxygen. We're going to start off with two gases, and then we're going to end up with a liquid somehow. And so we're going to have to see how this can actually happen. All right. So it says, let's read the instructions. So to start the simulation, click play at the bottom of the simulation. Then click spark to initiate the reaction. Pause to observe different states of the reaction. Reset the simulation and click on the button on the left. Okay, perfect. So let's go ahead and start our reaction. Let's see what's going on here. Oh, I'm so sorry. Before I start the reaction, I do want you guys to notice a few things. So in the beginning of this equation, we end up with two hydrogens and two oxygens. So hydrogen gas, which is H2, and oxygen, which is O2. We end up with water. Okay, so right now we're looking at the beginning of the reaction. So we have our two oxygens here, or two hydrogens, I'm so sorry. and our oxygen's here. So we have our H2 and our O2. So we're going to see what happens over time. So let's go ahead, and right now we're looking at our reactants. Okay, so that's the beginning of the equation. So our two reactants, okay. All right, they're moving around pretty slowly, right? So kind of just waddling around. As they bump into each other, the more they bump into each other, the more they start to move, if you do notice, so over time. But let's go ahead and initiate a spark. Let's see what happens. Let's turn off. So we are in slow motion now. Okay. All right, so we see a little bit more movement happening. Our temperature is slightly increasing. It's increasing more rapidly now. We see more movement. We start to see some, if you look at here, these are going to be your water, right? So we see more water happening. Okay, the temperatures continue to rise. Your molecules should be moving a lot faster now, bumping into each other, getting a little wild. Okay, and as our temperature increases, we should see more waters, right? We see less hydrogen and less oxygen, and we see more H2O. Okay, I'm going to go ahead and start another spark just for fun. So we can see our fun little slow-mo of a spark. So once it hits, we see some crazy stuff happening now. So it looks like the only thing, we're waiting for some of our oxygens to get onto some hydrogen so we can get only water. Okay, perfect. So, all right. And now let's go ahead and answer some questions. Oops, just give the answer. So it said, what happened to the hydrogen gas and oxygen molecules after you press spark? Okay, so this is my response. Most of the hydrogen oxygen turned into water, which we kind of saw happening, right? Because this is our water now. So the reactant is now water, okay? The other oxygen was released as heat. Oops, let's delete this. So it says most of the hydrogen gas and oxygen was turned into water. As temperature increased, once we hit spark, what happened, right? So once we hit spark, we saw the temperature quickly rise, right? Okay, so let's go ahead and leave that. So those are two things that happened. If you saw something else that we talked about, that's fine too. So let's just go ahead and click save and submit. And then it said, what happened to the temperature graph? What does this tell you about the energy released? So we can say the greater the temperature, the more energy that is released. Because when molecules are moving around really fast, it means that they have a lot of energy. So once we increase the temperature, we see that the molecules move around more quickly. And we can even add that here, sorry. The molecules, we can say, as a result, the molecules move around more quickly. Okay, that's a pretty good answer now. Now we'll finally click save and submit. So the greater the temperature, the more energy that's released. Actually, boy, the more energy that is released as a result, right? And we can kind of see that here in the beginning of the equation. All right. Okay, finally. So I'm going to go ahead and click reset on this just because I want to show you how to do it. So it says, how do we start with 6 hydrogen gas molecules and 3 oxygen molecules and end up with 6 water molecules? Because we know that this has to equal one another, right? Because, so we have 6 hydrogens. Okay, so if we have 6 hydrogen gas molecules and 3 oxygen molecules, we end up with 6 water molecules. We have to remember that matter can never be created or destroyed. It's only being transferred in one way. And right now, looking at this equation, sometimes it doesn't, I mean, to me, since I do know, it doesn't look like it should add up, right? We only have 3 and we end up with 6. Something seems weird here, right? So let's kind of make sure that we understand what's going on specifically, because really nothing's changing. Just the type of atoms are being split and the molecules are actually changing. so that we have different elements that are here. So let's go ahead and go to this. So our stamp. So we're going to draw the before reaction. So this is our reactant. So let's go ahead and start off with our 6H2. Okay, and before, if we look at it, so we have our hydrogen, so that they're in the gray. Okay, so 1, 2. Okay, that's our 6H2. Okay, 1 and 2, 3, 4, 5, 6. Perfect. Okay, so we end up with our 6 H2s, and we're going to go ahead and draw our 3 O2s. And again, okay, we're going to look up here at the example given to us. So let's go ahead and draw 1 and 2, 3 and 3, sorry, 2 and 3. Okay, so then we have our 3 O2s. All right, perfect. So we're going to go ahead and leave this, click save and submit. So that is our reaction before. Then let's go ahead and now it says step 2. It says click the reset button below, then click OK. Yeah, because that's my other one. Oopsies. We'll click reset. So it just gives you the equation from up here. And then perfect. So we're actually not going to add any other molecules. We don't have that option. So what we're going to do is we're going to go ahead and move things around so that we can make sure that we're meeting the reactants. The products. So these are reactants, so we're going to move them around to make our products. So really what we have is 6H2O. So let's go ahead and start off here. So we have 6 H2s, right? Because that's what that means. So we have 6 H2s. We actually multiplied this number by this, right? So again, we're starting off with the same thing. So 1, 2, 3, 4, 5, and 6. All right. And then we have to go to our O's now because we technically still have O's in this equation. So what we're going to do is we're going to move these guys around. We're going to go ahead and put 1 right here, 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 and 1 right here. So do we actually have 6 H2Os? We didn't add anything, right? We just moved things around. It was exactly the same. So really what you're doing is you're actually multiplying this 6 right here too. So if we add all of our molecules up, we actually have 12 and then, right, 12, and then we have, oops, oh no. 12 and 3 times 2 is 6. We have 28. And then we have 28 elements at the end as well. So again, matter is never created or destroyed. So go ahead and click save and submit. Perfect. You guys did a great job. Okay, make sure you have a little check here. All right, so now for today's assignment. So we're going to go ahead and complete this in the same way. I want you guys to go ahead and do it first so that you guys do have an understanding of what's going on here. So let's go ahead and go back. Set up. So make sure you click setup and then go. Okay. And I want you guys to make sure that you're using the key up top, okay? The directions are pretty self-explanatory, so make sure that you're actually reading them, okay? They are important. All right. And thank you so much. I hope you guys enjoyed this video.